Thank you, everyone. Let me just see what's happening here. Oh, I don't want that. Okay, sorry. Yes, so assess the analytical variability with BrainLife. So first, what's BrainLife, right? So BrainLife is a neuroscience analysis platform. It's a platform that we've been developing for the past 7 years, and we have, and it's all web-based, is free, secure, open source, and it's everything happens in the web. So no, you don't need any terminal. You navigate through your data as someone is showing here. You have a lot of metrics and integrations with different data types that we allow. But what I want to do is first start with motivation regarding the burden of neuroscience. I believe people here are in different stages in their careers. Oh my God, the slide's very strong. And at some point, or you will, or you have been through several issues with research in neuroscience that you need to make it to make sure that you're doing a good research. So first, data management store, data analysis, pre-processing, data ingestion, quality assurance is a very big one, and feature extraction and sharing and publication. So we have to deal with all this, and that's very hard for us. So what we propose and what we believe in are in integrative infrastructure. We believe that we need to have end-to-end solutions in which we can take the burden out of the researcher, and we can help them, or help you to make a good research and an accurate research without all the hassles that we go through. So this is our team, Franco Pastilli, our PI, and a bunch of engineers, postdocs in different levels of their career. So what we do in BrainLife, we try to go end-to-end, and we go from the beginning, from importing data, going through your DICOMs, and giving it a good, and helping converting the DICOMs into beads, and then archiving these, making sure that the data has a good quality. You can do manual insurance, or we have automatized methods to do quality insurance. Then we provide ways of doing processing and feature extraction, statistical analysis of brain features, and to the end, the publication of your data sets and everything that you've done to your data. So it's a lot. And the important thing is everything happens in the web. So if you close your browser, you can go home and have a good night's sleep, and you come back the next day, probably early in the morning, and it's going to be there. Everything is going to be running while you've been sleeping. So BrainLife is supported by 4 main pillars. That is data archives, data standards, software libraries, and compute resources. I'm not going through this workflow, but we handle a lot of infrastructure to be able to deliver to you this end-to-end solution. So in the first pillar, data archives, we have full integration with OpenNeuro and other data sets, such as the OHBM from the Child Mind Institute, in which you can visualize different kinds of neuroimaging data, and you can import them to your project. So if you want to do let's say an extensive study, including several data sets at the same time, you can do it, and you can go through it in our platform. So here's an example on how we do that. We basically have a list of all the data sets from OpenNeuro, so you can check out for the descriptions. You can say, you can check the kind of data that they have. So for example, this is anatomical, the WIM functional. The person is only picking up the diffusion. So it creates a whole new project for you with all the 260 subjects ready for you to start playing around, and with all the metadata that are necessary to do research. You can visualize. Let's see if we can speed up this video. Oh, it ends, okay. So the data from the archive, they become actionable. They are not anymore just that data in that specific cloud that you need to download and you need to interact with it. Now it's ready for you to use in, what, 1 or 2 clicks, and ready for you to start analyzing it. But there's another option that you can bring your own data. So we provide, together with BrainLife, the tool called EasyBeads, in which you can, it provides you a user interface to go through your DICOMs. That it's a very messy process to convert them to nifties or other data formats and everything into the beads standard that everyone knows. So with the help of some heuristics and some clever things, we can go through all the data and we can help the user to validate if the metadata about the neuroimagings are correct, and they can adapt or not based on that. And in the end, you get a fresh new beads data set that you can publish to OpenNeuro directly, or you can send it to BrainLife for analysis. So it's a very straightforward way of going. So you don't need to touch any terminal, although like there's some black text over there. That's not terminal for sure. So you can check out if you have data, if you want to give it a try. And right now we are converting this tool into what we call into edge computing. So everything happens in the browser. So if you have PII data, if your DICOM have some metadata that should not be shared, nothing will be uploaded to our servers. Everything happens in your browser, and you still get a clear, nice, fresh beads data set in the end. And our third pillar is the software libraries. We support these amazing tools that the community built. So fMRI Prep, FreeSurfer, DiPi, we have them all converted into a certain specification that is supported by BrainLife. And together with Ashley and Joshua from the NeuroDesk team, we are now facilitating bringing new tools into the platform. So if you want to try another version of a certain tool, or if you want to try new tools, you can easily create your own. You can import this tool into BrainLife. But most importantly is that we keep track of what we call data types. So data types is the glue between the different software that we have. So for example, if we are running fMRI Prep for anatomical and functional preprocessing, you may not want to include your diffusion data there because it might not be pretty. It doesn't make much sense. So we have this information regarding how the software is glued together, so the user is less prone to make any sort of mistakes regarding where the data is going or coming from. And we also have a cool a provenance graph. So provenance graph, it's all the steps that you did to get to the data that you're looking at. So in this example, we have resting state. Do I have a mouse there somewhere? We have a resting state fMRI and a diffusion imaging. No, sorry, T1 imaging, going through FreeSurfer and going through fMRI Prep and finishing up into a preprocessed both image. Interesting. So you can think about these as the sort of proteins structures that they can only glue together with certain receptors, and we have everything tracked for you. And the fourth pillar is compute infrastructure. So BrainLife relies on government-funded cloud infrastructure. So we have across the US access to a lot of compute, and we provide that for the users for free. So if you access right now BrainLife and you import data and you want to preprocess everything through fMRI prep, things will go as expected for free, like no charge, nothing. And we are integrating with other clouds, and we're bringing integrations with different institutions. So if you have restrictions, for example, in Europe for GDPR, we have infrastructure integrations that people can run everything in their own clusters, so they don't need to worry about data traveling around the world. We are thankful to have an extensive user base across the world. A big part in US, in Europe, because that's science right now, but we have a large group in South America and Africa, and hopefully we'll bring more into Asia and Oceania as well. Let me see, how much time do I have? 18 minutes, okay. So what I'd like to show you now is actually the platform, right? And be talking a lot. So a demonstration will be that I like to do regarding assessing pipeline variability is running two diffusion MRI preprocessing, in which I'm changing the first step, that is using different libraries to do the initial preprocessing step, and see in the end which metrics were changed and how things are changed in the final result. So let me see how I do this now. All right. You guys can read in the back? Oh, good. Yes, so here we are in BrainLife. This is let me show you actually. This is your main page of projects. You can create as many projects as you want, and that's our way of creating, let's say, a study. Oh, internet's very slow. Creating new studies and encompassing all the preprocessing and data into. All right. So it's web-based, you need internet. That's the only thing you need, I swear. So let's do something that I have open already. So yeah, the thing that I really like to show you is how to run these pipelines. So going through Analytical and QSI prep, which are two software libraries to perform DWI preprocessing, and then doing tractography, running free surfer, doing tract segmentation, and seeing how in the end the tract profiles show up. I got from my hotspot. Thank you. Yeah, so what I did is I got one subject from HCP, from the Human Connectome project, and I was able to preprocess it just based on the T1, the original T1 image and the DWI image. From there, I was able to generate different derivatives of this data. So what I did is in the this preprocess tab, I created two pipelines. One it is for QSI prep, another for Analytics, and then I was able to create the whole pipeline eventually. Yeah, so you can see here, for example, what I did, what in BrainLife you would do is you would submit an app. So each software library is what we call apps in BrainLife, and I run Analytics preprocess. which will do a first step of preprocessing of the diffusion imaging. And we have nice metrics regarding the outputs of it. And then we would actually run tractography, which will provide us already some metrics regarding count of tracts and length of fibers. So we can have already a quick QC, a quick QC moment to check if your data is running well, and if your data has any sort of problems. Then I run fMRI prep, which also shows you some statistics regarding white matter parcellation and cortical thickness and volume, and show some images. So we can see here that the segmentation of the tissues were pretty fine. Then I performed white matter anatomy segmentation, which will group the streamlines of the tractography into their own parts, into specific segments, and a cleaning up app just to remove the final whatever is not included in these tracts. And we can see here as well, we can always, during these steps, we can perform QC and see how things are going with the data. And the final step is where we want to see the actual metrics, how certain metrics regarding tractography or the fibers, how they are. So we can compare, for example, fractional anisotropy to other data sets. So the blue line here that has a dip in the center, it is from this specific data set, and we can compare how are the metrics for other data sets such as HCP, CAMCAN, and PING. And we can check in other structures. So this is the anterior frontal corpus callosum. So the dip here may be dubious. Let me see here. Yeah, so we can check for each of these data sets how the quality is, and we can we can check these metrics to be able to compare between the pipelines. So I tried that with QSI prep as well, because I wanted to see what the results of that. And the fun thing is that in the end, I had, it's loading eventually. I had nothing. And well, that's an issue, right? So what happened to my data that I have nothing on it? So what I do is I backtrack all the steps that I did. So going from track the analysis profile, remove outliers, I check the segmentation, the white matter segmentation, and it shows already some errors. So some tracks have less than 20 streamlines. So you need to backtrack in your original data and see what is affecting this. So for example, I can show you in this visualization of the tractography that everything seems okay at the first look, at the first sight, but if we check just, for example, the arc rate, we can see the right arc rate, it's very fuzzy. It has not much streamline, so that might be an issue with the preprocessing step that we did differently than the MRI tricks. So what we can do is we can change parameters. We can try another ways of preprocessing to be able to reach to the end of tractography in a good with a fair quality data. However, if I want to do that for, let's say, 100 subjects, it will be very massive because I need to submit an app. I'll go free surfer for each subject. And that's just too much to do, right? You would take a lot of time to create for each subject. So we have this feature called pipelines, in which you can create a a set of apps that are going to run for all the subjects in your project. And as new subjects are added to the project, it will also preprocess them. So for example, we can create a group here and call Matrix. That's a good color. There you go. So we have now this group of apps that we can run, and we can add, let's say, free surfer. And as we add, we can try different versions, older versions of free surfer. Oh, actually, I got an older version of free surfer. So as new software present, for example, bugs or things that might impact the results, we can deprecate certain softwares and in face of new ones. So for example, here I'm creating a rule, a new execution for free surfer, and I'm setting some parameters. So you can change the parameters as you want to try to test how the variability in your pipeline affect the results. And once I press OK, in my project, I have then the free surfer, and this pipeline should, it will start processing subjects that do not have the free surfer data. So that's a useful way if you want to go through a lot of subjects and a lot of pipelines in one click. You can create your own rules, and you can get all this data. But now the problem is you have too much data. Now how do you analyze all this, right? So the next step will be the Jupyter notebooks, of course. So we provide a Jupyter notebook environment in which you can compile all these measurements across pipelines, and you can generate statistics on it. So for example, here I have the FA, the fractional anisotropy, and we can see for some areas there's no fractional anisotropy, so there might be some quality issues. But for the corpus callosum, there are some fair fractional anisotropy. So we can go across these data frames, and you can generate statistics, and you can compile all this information in one go. So all the data that you generate in the preprocessing steps, it will be available in the Jupyter notebooks for you to query and for you to analyze it. And one last step will be publications. So now that you've done all this work, you want to show people that, hey, these are the results that I get, and avoiding the issue that was previously mentioned of just showing the results that are valid. You can actually create a publication with all the pipelines that you tried and what failed and what not. So when you create a publication, all the data and the pipelines that you run will be compiled into one DOI that you can use to cite, and it's a valid DOI. You can cite into your papers, and for then people to reference to your analysis and see that that's what you actually did into your study. Let me go back here. So in just some clicks, we can compare two pipelines. I just did one subject with, if it was 1 or 300, it will not matter because we provide ways of doing it automatically. You just need to wait a little bit for everything to process, but things will get done eventually. And there are upcoming things in BrainLife. So I would suggest to register today or through OHBM, so you get into the mailing list. But we are working into BrainLife organizations, which is a way for you to manage projects and resources under your institute. So if you have a cluster that you want to connect to BrainLife for your own use, we are providing ways of doing that. We're also working in the BrainLife Hub for you to manage and monitor all the pipelines across your organization. I'm working, and that's my PhD, I'm working on BrainLife AI. That is this agentic AI for you to get to interact with BrainLife and into this sort of rich media environment. So you have visualizations, you have plots, you have forms that you can interact with not only BrainLife, but we are also adding other platforms such as OpenNeuro, and the next one is eGov. And you can check out my posters on the last 2 days, poster 1856. And there's also, since we try to provide this end-to-end solution to researchers, we also work in data governance, which turns out to be very important when we are collaborating across institutes or across countries. So we have this platform for you to manage your data governance documents, and I also have a poster about that. And I'm very thrilled to announce that we also got the open data storage on AWS. So now we don't have more limitations in terms of storage. So if you have a massive amount of data that you want to bring to BrainLife for analysis, now it's available. So register today, and I'm open for questions.
Is there any way to contribute by adding more enhancing tool to BrainLife analyzing pipeline?
Anibal, can you repeat the question?
Yes. So he asked about if there's ways for you to bring your analysis pipelines to BrainLife, and most certainly we do have. So we have this concept of apps. So what you're gonna do is you're gonna create your own GitHub repository with your code, and just do some sort of interface with BrainLife. That we have whole documentations about it, and the team is also open to help. But you can create your own software, your own app, and after some reviewing process, we will allow it into the platform. And yeah, you can bring your data, bring your libraries, everything. And together with NeuroData, we're also encapsulating new containers more easily with Joshua Neuro. Yes, exactly. Tool, so you can more easily bring new tools to BrainLife. More questions? Sorry, I cannot see people.
I have one question. Is there anyone in the audience have questions? Okay. I like the idea of having the graph to show the validation of different pipelines and different data sets. Yeah, that one. When you publish your pipeline, would you keep the transparency and show other user these kind of data as well?
So when you publish your data, it is not included in this graph because this was part of a study, but certainly it's something that could be considered to compare with other people that published in BrainLife, for sure.
Another thing about data, if users have private data set, do you support them to upload it into a private repo like OSF or?
Right. So if they have their own private data, they cannot publish it openly. BrainLife, when you create a new project, the project is by default private. It will not be shared with public. But if you have PII issues that you cannot neither upload to BrainLife, we are providing ways in which once you upload to BrainLife, the data is still in your institution and it doesn't move around any of our servers. So everything will be contained in your own resources.
Yeah, thank you.
I just have a question about the method that you were talking about, like matrix or this, like where you just click and does everything for you. If somebody is not much familiar with these details of the technique, how can they write the method about it?
Yes. So we have some approaches to this. Let me see if I can show you here. So one way of going about it is that we compiled across all the BrainLife usage specific pipelines that users mostly use. Wait, where is the? I'm trying to find where's the page now. So we compile a set of pipelines that a user can reference to. We also have tutorials for specific data types. So if you want to preprocess diffusion data, functional, and you want to do like network analysis, we provide a set of tutorials so you can use that. And the third step would be the new BrainLife AI that we'll hopefully publish by July, in which you can basically ask.
Like LLM.
Yes, exactly. So you would query, I have this data, how can I do, how should I do? And it can guide you through the process of creating your own pipelines.
But the question is about how you write the method section of your paper.
Yeah, for details of it, I think it will provide, I think the LLM will give you the description how you actually didn't do it, but how this did it for
Yeah,
you.
for sure, yeah. Each app has its own descriptions, and it can be compiled into a method section.
You can show a README file.
Yeah, exactly.
Free surfer.
Yeah, for sure, I guess. Or let's say fMRI prep, they would give some description about what the app does and how it goes through the. It's a very simplistic description. It can be improved, but each app is maintained by its own developers, so they need to provide more informed. Let's see, ensemble tracking. Where's free server? I cannot find free server. Yeah, so let's say this specific app for doing longitudinal free surfer, it will provide some information on how you can get more, in this case, more information about the longitudinal pipeline of free surfer.
So can you mind if I answer?
Sorry?
Do you mind if I answer?
Please, yeah. I mean, Franco Pestilli, the PI.
Yeah. So if you go to README, so there's a couple of places where you can find information about what you did. One is the parameters that you clicked when you used your app. Those are saved in your project, and they're attached to each one of the data types you created. So you can go back, and that's what Anibal was trying to show you, how you can go back and find which app you use and which parameters. And then this is not a good example because this is being built. But if you go to Free Surfer, most of the apps have full descriptions inside the README file. Anibal was showing the short description, but there's a README file on the GitHub repository. README, yep. Right. That should provide full information of which app you use, which software you use, and how you can reconstruct. A little bit.
Yeah, any more questions? Good. Please.
Just a silly question.
Mm-hmm.
Is it slow? Like, for example, if we use a free server as an application, is this through this BrainLife going to be the same? It's going to take the same time or faster, probably?
It could, yeah, it's relative, but it can be faster for sure because we're running in clusters, so it depends on.
That's what I was thinking.
Yes,
Okay, cool.
so it can be faster, it can be slower, depending on if you have access to other clusters. But yeah, in general, yeah, it will take generally the same time.
I have another question. It's more about the clinical application of those. This is a great tool. I mean, it's web-based, and clinicians can use it in hospitals. So have you thought to apply this?
Certainly, yeah. So our the first tool that I presented called EasyBeads, it's certainly one of the first steps that we would work with imaging centers, for example, to collect the data and convert it to a ready to analyze data set. So it will get the DICOMs from the MRI and will compile it into better formats that we can run through BrainLife and do their analysis in the clinical setups.
Yeah, and another question, sorry.
Of course, please go.
Converting the DICOM files to bits through Nifty, is it automated?
Yes. With this tool, it's automated.
I mean, being a clinician, can I just click, insert my patient's data or upload it or whatever, and then it takes everything automated afterwards?
Yes, so most of the things are automated. There might be some peculiarities with your data that you need to provide more information, but in general, it's just like clicking and typing. No, it's very informed, step by step.
Yeah, beautiful. It was developed since last year. I've seen your stall last year in the exhibition, and this is amazing, actually. Thank you.
Thank you.
All right. If there's no other question, thank you, Anibal.
Thank you, folks.